Hello my dear students, welcome to the YouTube channel of Unique World Education Dubai. This is Faslur Rahman, Chemistry Faculty of Unique World Education Dubai. Today we are going to learn about coordination compounds. So this is a very important chapter of inorganic chemistry coming for grade 12. So as you know, in organic chemistry we have only two chapters in grade 12, that is one is coordination compounds and the other one is D and F block, and both are very connected also. So coordination compounds is a very important chapter, like for example nomenclature of coordination compounds is a very important part of this chapter, and we have certain theories as well, like valence bond theory is there, Werner's theory is there, and crystal field splitting theory is there. Today we are going to learn about valence bond theory and nomenclature. So first I will teach you about how to assign name for coordination compounds, and then valence bond theory. Okay, so we can start. Coordination compounds. So first I will tell you what is a coordinate bond, or how a coordination compound is exactly formed. Okay, so for example, I hope all of you are very clear about the bonding. So you know about different types of bonding, like ionic bonding is there, covalent bonding is there, okay, then metallic bonding is there. So covalent bond, all of you know covalent bond. So covalent bond means just that is formed between two non-metals and which is formed by sharing of electron. Okay, so exactly this is a typical covalent bond. So A is sharing one electron and B is also sharing one electron. So this is a typical covalent bond. But when we come to coordinate bond, it is also a type of covalent bond. Type of covalent bond means that's the type of sharing, right? So type of covalent bond means sharing itself, but what is the difference means? So listen, A, B, two components are there. You can see one single headed arrow here, this arrow mark. So what this arrow mark indicates? That means only one of the participant will be sharing electron. Okay, so if I mention two electrons here, the meaning of this particular bond is both of these electrons are shared by A only A. So coordinate bond is like this. Coordinate bond is like this. A central metal atom will be there and a ligand will be there in a coordinate bond. So the ligand will be sharing both of the electrons. So this type of sharing can make a coordinate bond. Okay, can make a coordinate bond. So ligand should be electron rich, or you can say ligand should contain at least one lone pair of electron, then only it can act as a ligand. So and vacant d orbitals, or at least vacant orbitals should be present in the central metal atom also. Okay, so this is a coordinate bond. So coordinate bond is formed by ligand and central metal atom. In this, the ligand will be sharing electron. So I think the point is clear. So now we can check some coordination complexes and we can assign name for that complexes. So before that, you should have an idea about ligands. Okay, different types of ligands are there, like monodentate ligands, bidentate ligands. So I will give you some important examples of ligands first. For example, monodentate ligands means they can make only one coordinate bond at a time. For example, OH minus, okay, OH minus ligand, ammonia ligand, NH3, then H2O, Cn minus, okay, like that many ligands are there. All these are monodentate ligand. Okay, then halogens, okay, Cl minus, Br minus, F minus, like this. Important example for bidentate ligand or didentate. So bidentate or didentate means it can make two coordinate bonds at a time. Okay, So two important examples are very significant here. One is EN. EN means ethylene diamine. Ethylene diamine or ethane 1,2-diamine. It's a very important ligand. It's a bidentate ligand. And the other one is oxalate ligand, which is C2O4 2 minus. C2O4 2 minus, oxalate. So these two examples are very important. They are bidentate ligand. Okay. So and En is a neutral ligand, that means charge is 0, and C2O4 2 minus, it is a negatively charged ligand, that is -2, charge is -2. Okay, then next category is polydentate ligand. Polydentate ligand. Polydentate ligand means it can make more than 2 coordinate bonds at a time. Okay, for example, the main example is EDTA. EDTA. So I hope all of you might have heard about EDTA. Is a very important compound. So EDTA is ethylene diamine tetraacetate. Ethylene diamine tetraacetate is a polydentate ligand. Exactly, it is hexadentate ligand. Hexadentate. What do you mean by hexadentate? Hexadentate means 6. That means it can make 6 coordinate bonds at a time. And charge of EDTA is -4. Charge of EDTA is -4. Okay. So you should know exactly about the ligand is of which type of ligand, and what is the charge of ligand. So both this information should be very perfect. Otherwise you can do the problems in this chapter. Okay. So what about the charges of this thing? OH minus is already mentioned there, that is -1. Ammonia is a neutral ligand, H2O is a neutral ligand, Cl minus, that is -1, and Cl minus is also -1. Okay. So now I will give you some examples for nomenclature. Listen. So we have certain rules for IUPAC nomenclature of coordination compounds, like IUPAC nomenclature of organic compounds. So I am not going to explain the rules in detail, but while doing these examples, by doing example we can explain. Okay. So I will give you some examples of nomenclature. So by doing that examples you will study the rules also. Okay, that will be better, I think. Okay. So I think about the ligand it is clear. Okay, so we can take one example, first compound. Yeah. So for example, CO is the central atom, and NH3, ammonia, 6 times, ammonia 6 times Cl3. Okay. See, a coordination complex, actually coordination compounds are called complex compounds. Complex compounds. Why? Because their structure is complex. Okay, you can see their structure is little complex in nature. So they are having a part which is in a square bracket, and one part is outside the square bracket. Okay. So the part which is inside the square bracket, that is called coordination sphere. Okay, coordination sphere, that is the main part actually. So that means this is the coordination sphere, and this part is called ionization sphere or counter ions. Ionization sphere or counter ions. Inside the coordination sphere, again you have 2 parts. See, in this one, cobalt is the central metal. Cobalt is the central metal, and ammonia is the ligand. Ammonia is the ligand. Okay. So inside the coordination sphere, you have central metal atom and ligand. Okay. So that ligand may be only one type, or different types may be present. So we have certain rules based on that. Okay. Anyway, central metal atom will be at first and then ligands. Okay, but when it comes to nomenclature, it will be opposite. So first you have to name the ligand. Okay. Now I will tell you how to name this compound. So you have to start with cation. Okay. How you know which is the cation, which is the anion of this complex? Listen, you know ionic compounds. Ionic compounds you can split into two ions, two or more ions, negative and positive ions. For example, a very simple example, NaCl. NaCl is an ionic compound. You can break this ionic compound into Na plus ion and Cl minus ion. Na plus ion and Cl minus ion. Correct. Okay. That means in an ionic compound, equal number of positive and negative charges should be there. That means negative and positive charges should be equal, or the compound should be neutral as a whole. That's the concept. So same thing you can apply here. So listen, this you can make one part. Okay, Cl3. What is the charge of chlorine? All of you know chlorine is a halogen which is having a negative charge, I mean -1. So Cl3 means that is 3Cl minus, right? 3Cl minus. So this is one part and charge of that is 3 minus. That means each chlorine 1 minus. So Cl3 means 3Cl minus. So what is the remaining part? So this will be the remaining part. Okay. So that will be CONH3 6 times and the square bracket. So what will be the charge of this one? See, one part is 3 minus. So the other part should be plus 3. So this is 3 plus. Okay. So this is the charge of the square bracket. So now you split the compound into two different ions. Okay, negative part and a positive part. Now what you have to do means, listen, so which is the cation? So this is the cation and this is the anion. So you have to start naming with cation. Okay. Inside the cation, or inside the, as the cation is coordination sphere, you have to start with ligand. Naming, you have to start with ligand inside the square bracket. So listen, in this compound, ligand is ammonia. How many ammonia ligands are there? 6 ammonia ligands are there, and central metal atom is cobalt. Okay. And one more important thing, you have to find out the oxidation state of the central metal atom. See here, you can see the central metal atom is cobalt. Okay. Actually, the proper method is like this. So you can give X, you can assign X to cobalt, I mean X to the central metal atom, which you are going to find out the oxidation state. So X plus, how many ammonia ligands are there? 6 ammonia ligands are there. What is the charge of ammonia? I told you ammonia is a neutral ligand, right? I hope you remember. So charge is 0. So 6 into 0 is equal to what is the charge of this total ion? That is plus 3. Okay, plus 3. So that means X is equal to plus 3. That's it, very simple. Okay, because this term is 0. Okay, so listen, if the square bracket coordination sphere contain only a neutral ligand apart from the central metal atom, the charge of the square bracket itself will be the oxidation state of the central metal atom. That means here you can see this 3 plus will be the charge of CO, central metal atom cobalt. Okay, so now that's very easy. Now listen, here 6 ammonia ligands are there. 6 ammonia ligands are there. Ammonia is named as amine in a coordination complex. That is the original name of ammonia. So how many ammonia ligands are there? 6. So hexaamine, hexaamine. So listen, this amine should have two M, double M. Okay, hexaamine, then cobalt. Cobalt is a central metal atom. So after naming the ligand, you have to name the central metal atom. Hexaamine cobalt, hexaamine cobalt. Then after the name of the central metal, you have to put a bracket. Inside the bracket, you have to mention the oxidation number of the central metal atom in Roman letters. Okay. So what is the oxidation number? +3. So 3 in Roman letter. Okay. 3. So after that, you have some counter ions as well. Outside the square bracket, you have 3 chlorine atom, right? So chloride, chloride. Okay, so this is the name. So no need to mention the number of counter ions and all, like trichloride and all. So just chloride is enough. So this is the nomenclature of this particular complex. CONH3 6 times Cl3. So I hope it is clear. Hexaamine cobalt 3 chloride. All of you clear? Okay. So I think we can do one more example. Just wait. Then we can move to the next topic. So for nomenclature, the very important thing is you must have a clear idea about ligands. Okay, like the name of ligand, charge of ligand, density of ligand. Okay, and calculating oxidation number of the central metal atom. Everything should be very perfect. So without this knowledge, you can't name a coordination compound. Okay, like organic chemistry naming pattern, same thing. Okay, so we can do the next example. Yeah, second one. So the concept is clear, right? Okay, so we can do the second one. Okay, this is a different type. K4FeCN6. 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 Okay. In the previous compound, the counter ion was chlorine. Okay, that means that is after the square bracket. I mean, after the square bracket. This is in front of the square bracket. So actually, if it is a cation, if the counter ion is a cation, that will be at front, and if the counter ion is an anion, that will be after the square bracket, after the coordination sphere. Okay, right side. So first you have to name the cation first. Cation. So which is the cation here? Which is the cation here? Potassium. All of you know potassium is a cation. So how you can split this compound? 4K plus. 4K plus. Why? Because 4 potassium are there. So 4K plus and the complex ion FeCN6. FeCN6. So if that part is 4 plus, this part should be 4 minus. Okay, 4 minus. Yes. Now what will be the starting of the name? Potassium, because potassium is the cation. Okay, so potassium. Potassium. Okay, then ligand. So can you please tell me which is the ligand here? Which is the ligand here? You can see Fe is there and Cn is there. Fe is the central metal atom and Cn is the ligand. Okay, Cn is the ligand. So you have to find the oxidation state of Cn here, the ligand here. So listen, see what is the charge of Cn? Charge of Cn is -1. How many Cn is there? 6 Cn ligands are there. So that is -6. Okay. you have to find the charge of this iron central metal atom using this charge. Okay, see, this is -6 and this is -4. So this should be, that means like x plus -6 is equal to -4. Okay, so x is equal to 6 minus 4 is equal to +2. Very simple. Okay, you can just think like this. Listen, this is -6, right? Okay, Cn is -6. Inside the square bracket, the total charge is -6. Okay, and you should get -4. So this should be what? That should be +2. So 2 minus 6 will become -4. That's it. Okay, so your charge is +2. That means oxidation state of central metal atom is +2. So that's ready. And you have to name the ligand. You have to name the ligand. So the ligand is Cn. Cn means cyanido. Cyanido. If the ligand is negative ligand, you have to end the name of the ligand with a suffix O. Okay, like cyanido, chlorido, bromido, sulfato, nitrito, oxalato, like that. Okay, so how many Cn ligands are there? 6 Cn ligands are there. So potassium hexacyanido, potassium hexacyanido. So ligand is finished, then central metal atom. One more important thing, see, in this complex the charge of coordination sphere is negative. If the charge of coordination sphere is negative, you have to add ATE to the name of central metal atom. Okay, so all these are rules. So we are studying rules for nomenclature by doing examples. Okay, so potassium hexacyanido. So how you can name the central metal atom? It is iron, right? But you have to write ferrate. Ferrate. Okay, why ferrate? The name of iron is ferrum. All of you know that. And why this ATE? Because the central, the complex is negatively charged. Okay, so ferrate and oxidation state. What is the oxidation state? That is 2. So in square bracket, Roman letters. So this is the complex. Okay, potassium hexacyanidoferrate 2. Potassium hexacyanidoferrate 2. Clear? I think we can do one more example. I think the concept or the rules are clear. So we can do one more example. Then I will give you a homework also. So you have to give the answer in the comment box. Okay. So we can check how many of you are getting the correct answers and how many of you are having confusions and all. And if you have any doubts regarding this particular topic, you can come in comment box. Okay, and you can suggest also which topic you need for the next class. We can do that. Okay, so we can do one more example right now. So I think this is clear. Okay, coming to the next example. Okay, the central metal atom is scandium here. Scandium is Sc. NH3 3 times and H2O 3 times. H2O 3 times, then square bracket and 3 plus. Okay, so this is a part of complex. A ion is given, an ion is given. So same rules only. So can you please tell me which is the central metal atom here and which is the ligand here? So it's very simple. You can see scandium. This is the central metal atom. Here you have two types of ligand. Which are they? ammonia is one type of ligand and water is another type of ligand. Okay, water is another type of ligand. So we can check how this is named. But before that, you have to check the oxidation state of scandium. So as you know, ammonia is a which type of ligand? Ammonia is a neutral ligand. That means charge is 0. What about the charge of water? Water is also a neutral ligand. Then it's easy. What is the charge of this? What is the oxidation state of scandium? That is +3. Okay. If the ligand's presence inside the square bracket is neutral ligand, then the charge remaining on the top of the square bracket will be the charge of the central metal atom. So directly you can write scandium. And one more important thing, I think you know this particular topic, like particular point. Scandium, if the central metal atom is scandium, the charge will be always +3. Why? Because scandium shows only one fixed oxidation state, that is +3. That is because of the stable oxidation state that we will study in D and F block chapter. Okay, so that is a very important point. Okay, see here you have two ligands. One ligand is ammonia, so that means that is amine. And if water is the ligand, the name you should write like aqua. So if more than one type of ligand is there in a complex, you have to follow alphabetical rule. Okay, so here both are starting with A, so you can you can check the second letter. Okay, M and Q, so definitely you can start with ammonia. Okay, so how many ammonia ligands are there? 3 ammonia ligands are there. So the name will start with triamine, then 3 water ligands, so triaqua, then central metal atom. What is the central metal atom? Scandium. Okay, so you can directly write scandium. What is the oxidation state? Oxidation state is +3. So write in bracket +3. Okay, 3 is enough. Ion. Okay, because this is a ion. So triamine, triaqua, scandium 3 ion. So this is the name of this particular complex. All of it clear? So it's a very important topic, nomenclature of coordination compounds. Okay, so 3 examples we did. I think it is clear. So I hope you understand the rules as well. Okay, so I am repeating again the important points. So first you have to name the cation. And inside the square bracket, that means inside the coordination sphere, you have to name the ligand first. And there are certain rules for naming the ligands, like first of all, if the ligand is negatively charged, you have to add the suffix O. Okay, example, cyanido, chlorido, bromido, like that. Okay, then if the ligand is neutral ligand, you can write the exact name like amine, aqua, like that. Okay, if it is En, that will be ethane 1,2-diamine. Okay, and if more number of ligands are there, you can use the prefix di, tri and all. Okay, and if more than same type of ligand is present, you can go with alphabetical order. Okay, then when it comes to central metal atom, after ligand you can name the central metal. So what you have to remember when central metal atom is named, you can directly write the name of the central metal atom if the coordination sphere is positively charged. But if the coordination sphere is negatively charged, you have to add the suffix ATE. Okay, like nickelate, okay, ferrate, like that. And you have to represent the coordination, oxidation state of the central metal atom in bracket, in Roman letters. Okay, So these are the important rules for nomenclature. So I hope it is perfect. If you have any confusion regarding this particular topic, you can put in comment box. And now I am giving you two complexes for your work. So you have to give me the answer in the comment box. Okay. So we can check how many of you understood this particular topic very well and how many of you are getting the correct answers. Okay. You will do it right. Okay. Just wait. Yeah. Okay. So your homework. First one. So I am just giving you two compounds, that's enough, because sometimes it will be confusing if I am giving you more questions for homework. So first one, MnH2O. It's very simple one, you can do it very easily. MnH2O 6 times 3 plus. Okay, first one. Second one, Ti. What is Ti? Titanium. Ti NH3 twice, En twice. What is En? Ethylene diamine. En twice 4 plus. En twice 4 plus. Okay. So these are the homeworks. So you can give the answer in comment box. Okay. One more thing. If En is coming as a ligand, you have to note one thing. First, the name is ethane 1,2-diamine. I am writing here. Ethane 1,2-diamine. Ethane 1,2-diamine, or you can simply write like ethylene diamine. Okay. Listen, I have told you like if same type of ligand is repeating 2-3 times, what you have to use? Di, tri and all. But in the case of ethane 1,2-diamine, here 2 ethane 1,2-diamine is coming. So you are not supposed to use the prefix di. Why? Because di is already coming in the name of the ligand. So you have to use a different prefix, that is bis. Okay. So instead of di, you can use bis. Okay. Instead of tri, you can use tris, like that. Okay. I think it's clear. So you can write the answers in comment box. We can check how many of you are getting correct answers. So first one, MnH2O 6 times 3 plus. Second one, Ti NH3 twice, En twice 4 plus. Okay. Yeah, good. So this is the naming of coordination complexes. Actually we started with like two topics. One is nomenclature and VBT. So I think VBT we can take in next class because it's already half an hour. So I think this particular topic is very clear, very perfect. Okay, if you have any doubts, you can come in comment box. So I will explain in next class. We can check the comment box and all, and we will clear the doubts and all. Okay. So I hope all of you are enjoying. So we will give you lessons like this according to your requirement. So you can suggest in comment box. So what are the topics you need, or what are the method you need, like for example, if you need any discuss any particular question, or if you need to discuss any particular topic from any chapter, we can do everything. Okay. So once again, I hope this particular topic is clear, and it's time to wind up. So we can wind up now. Hope all of you are fine. So see you in the next class. Okay. Bye all. Take care.